Let's try our step-by-step process for substitution on this integral, which looks pretty gnarly. Good news, this integral actually won't be too bad. So let's see how things go. What is step 1? Let u be some part of the integrand. Remember, integrand is this part. Integrand is what is inside of the integral. It's the function. So let u be some part of the integrand. Oftentimes, this is an inside function. So for our choice of u here, well, if we were doing a derivative, what would we think of our inside function here? Maybe this. It's not always going to be obvious for substitution. Sometimes you'll make a guess, and sometimes you'll guess wrong, and that's okay. We'll have an example of what that looks like later on in this chapter, or in this section. So let's say this is our u. Let's say u is 4 minus x squared. It's this inside function. Another more subtle thing to look for in your choice of u is we would really like u's derivative to be out there somewhere. And the derivative of this is negative 2x. Now, we don't have the negative 2, but we do have the x just sitting around out there. Talk more about that later too. All right, that was step 1. Step 2 is compute du, which is du dx times dx. So this is a little bit different than what we did in our mode introduction example, but it's basically the same thing. So du is du dx times dx. What is du dx? Well, we know exactly what du dx is. The derivative of u with respect to x is negative 2x. And again, we're going to follow this step-by-step process is a little different than that sneaky example I gave you, but there are a couple ways of doing substitution. Now, step 3 is going to be substitute everything in terms of u. Let's add to here. There's really kind of a step 2.5 because the substituting is a little bit more tricky here. Because we don't have a negative 2x dx. Here's what we have, right? So the bottom is the square root of u. That's great. And if you want, you can write this numerator as x times dx. Remember, you can think of this dx as dx over 1. Anything that's not a fraction, we can make a fraction. So we can put that dx in the numerator. So if we had a negative 2 right here, we could perfectly substitute and get everything in terms of u. That would be great. But we don't have a negative 2. Could we get one? Yeah. So you can't just make things up in math. Well, jury's out on that one. But in general, you can't make things up. But if I had something like, let's go over to the side, right? If I had something like 4x squared, wouldn't that be equal to 4x squared times negative 2 divided by negative 2? Aren't these things the same exact thing? So we can get a negative 2 in there as long as we pay for it. If we multiply by a negative 2, we need to divide by a negative 2. So we can get a negative 2 here. We just have to compensate. So I really want a negative 2 there, but if I multiply by a negative 2, I need to divide by a negative 2. And now this is going to be really nice because look at this numerator right here. This is exactly du. So what we have is the integral now of du divided by negative 2 times the square root of u. And we've completed step 3. We substituted everything in terms of u. We only have u's. And here's a little note that if you try to do this and you have x's left over, you may have made an error or you may have chosen a bad choice of u. We'll see what that looks like again in a future video. I think it's the next video. Great. Step 4 is to integrate. So I like rewriting this a little bit before I integrate. Let's take the -2 out of the fraction. We can do that like this. Dividing by -2 is the same as multiplying by -1/2. And then we have a du here. Let's rewrite that square root as u to the -1/2. Remember, the negative means the u is in the denominator, and the 1/2 exponent means square root of u. So again, the -2 went here, the du went here, and dividing, hold on, I have to make sure I'm using all the colors. Dividing by the square root of u is multiplying by u to the -1/2. That's what happened to everything. I know I did quite a few steps all at once. But I just want to rewrite this so it's a little easier to integrate. So now we have -1/2, and we can just integrate. This is just the power rule. We add an exponent, and then we divide by that new exponent. We're dividing by 1/2. Dividing by 1/2 is multiplying by 2. And we don't forget our plus c's. 2 times 1/2 cancels out. We're very close. All we have is negative square root of u plus c. What's step 5? Put everything in terms of x. Don't forget your plus c. So we have negative square root of u. And what was u? 4 minus x squared. And we have found our antiderivative. And that's what the substitution method looks like. So this step right here is probably the trickiest for a lot of people, right? Is we want to get everything in terms of u, but we might not have the right constant. And so we need to multiply or divide to get that right constant. And again, you can always check your answer, and it's a good idea to check your answer. How can we undo an antiderivative? Let's take the derivative. If we take the derivative of our answer, which is 4 minus x squared to the 1/2 plus c, we take the derivative of this, we're going to need the chain rule. We're going to usually need the chain rule if we're checking a substitution problem. Bring down the exponent. Inside stays the same. Subtract an exponent. Multiply by the derivative of the inside. Some good chain rule practice. Negative times a negative is a positive. 2 divided by 2 is 1. And what we're left with is an x on the top. This thing goes to the bottom because it has a negative exponent. And you can see that when we check our answer, we immediately get our integrand. Again, I'm going through this pretty quickly. You can do your chapter 2 derivative stuff with more steps, but chapter 2 is not a focus of this video, so I'm just going through it quickly to show you what it would look like. All right, feel free to review 2.5 especially for more derivative practice. But there's our antiderivative right there. So if you're feeling confident, I would recommend pausing the video and try to do this here. If you get stuck, unpause it just a little bit until you get unstuck, and then try to pause it again and finish it. Okay? So to do this, we're going to let u be some part of the integrand, oftentimes an inside function. U is what we traditionally use for the chain rule. And again, another thing that we want to look for is if we have a choice of u, can we find its derivative lying about somewhere? So here, this is my first guess of u. Let's see if it works out. It's not always going to work out. Sometimes you're going to have to guess multiple times. So if u is e to the x plus 15, what is its derivative? Its derivative is e to the x. That's great. We want its derivative to be lying around because we're going to need to use essentially the chain rule. Step 2 says, what is du? Du is du dx times dx. And we know exactly what the derivative of u is with respect to x. It's just e to the x. Oh, so this one's actually easier than part A. Why don't we do this one first? Because this right here is exactly du, right? We said du was e to the x dx. So look at our integral. The numerator is just du. The denominator is just u cubed. This is great. Again, be very careful. I'm going to rewrite this. Fractions mess things up in calculus. So let's rewrite this without fractions. This is u to the negative third power times du. That negative exponent puts it in the denominator. And now we can use the power rule. Add an exponent, divide by that exponent, plus c. We can think of dividing by -2 as multiplying by negative. Well, I don't think we actually want to do that here. The u to the -1/2 means it goes in the denominator. Sorry, I said -1/2. I meant -2. And so what we really get is that this equals negative, because we can bring the negative out in front. That's no problem. 1 over 2 times u squared. What was u? E to the x plus 15. That's getting squared plus a c. And that's our answer. And again, you can check your answer here to see if you have it right. If you take the derivative of our answer, and you could rewrite this like this if you wanted. If you take the derivative of this, you'll get our original integrand. We'll end up using the power rule. This -2 comes down and it cancels with that. We have to multiply by the derivative of the inside function. The derivative of the inside function is just e to the x, so that's where that e to the x on top comes from. And you'll get that it does indeed check out. So again, you could follow these steps, and you could get our original integrand of e to the x over e to the x plus 15 cubed. Don't want to take my word for it? Why don't you derivify itself? Differentiate is the actual word, but I sometimes like making up words. And that's basically it here. I promised I'll show you what happens when it goes wrong. That will be the next video, because it will go wrong, and that's okay. So don't panic, get some practice, and good luck.